Hey there, logic students. This is your professor Emilianchuk, and today I'm going to be talking about arguments, especially validity, valid arguments and invalid arguments, and what's the difference. And we'll talk about sound arguments and unsound arguments. All right, so this is also kind of a lecture about a big central topic that we'll be visiting and talking about in the coming lectures here, so pay attention. And also just revisit the last lecture about entailment, because that's really important. That's a central concept it's a key concept for understanding validity, right? Just kind of remember to refresh your memory here. P logically entails Q in a language if and only if P is true. If all the models in which P is true are those in which Q is true as well. All right, so one of the things that I want you to draw your attention to is the fact that, entailment can not only just relate two assertions together, it can also relate a set of assertions to another one. All right, so if you remember this argument here, if A is an F, then A is an G, A is an F, therefore A is an G, there's just no way the world could be where the last assertion is false and the first two are true. All right, so that's important. Okay, and we want to talk about that set of assertions doing some entailing work. All right, because that's going to get us into how we just understand our argument form and our notation here. One of the things that I just need you to understand about the syntax of our arguments in this class is that we have basically a collection of assertions, all right? And some of those assertions are called the premises. You might just have one premise, you might have two, you might have more, all right? It doesn't really matter. And then you have those together relating to a single formula called the conclusion, all right? So what we're going to be doing is we're going to be symbolizing our arguments with this type of notation. We're going to put our premises in the curly brackets that indicates that there's a set that's in the universe here or a collection, all right? And then the contents here are separated by commas. So you have one formula that's a premise, and then we have a comma, and then might have some more all the way on down the line to Q, right? Those are going to be your premises, and then R is going to be the conclusion. So the way we'll kind of draw things up, we're going to draw things up like so. Okay, just for the kind of purposes of this lecture, we'll have kind of number 1, dot, 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 all the way to the number n, wherever Q is. So P is going to correspond with 1, and then however many that we have, Q will be n. That's the little variable number is going to be there, n. Right, we'll draw a line, and we're going to then use a little triangular dot pattern here to show that an inference is happening. That's a therefore type clause. Therefore R is the case. All right, so that's what's happening there. Okay. All right, so let's think a little bit harder about this. All right, let's think about arguments and their semantics. Okay, basically, kind of what we're interested in from a semantic point of view is that we want the premises taken together to guarantee the conclusion, which is happening in this argument here. The Socrates is a man, all men are mortal argument. Obviously, Socrates is mortal, right? Those two premises, right, guarantee the truth of the conclusion, right? But not so in this argument, right, that says Socrates is wise, which is true, of course, and all logicians are wise. That is also true, okay? But then you look at the conclusion, Socrates is a logician, and that's just not really the case, okay? He didn't really do logic. He didn't study formal logic. I mean, he was a great philosopher, don't get me wrong, but Aristotle did most of the work when it came to figuring out how logic works at a formal level, right? So anyway, the big idea for you all is that entailment holds here, but not here, right? Because it's impossible for this to be true, for this to be false here, and these two premises to be true. Where it is possible for these two to be true and this one to be false, okay? All right, that leads us to our concept of validity. All right, now validity is a little bit different in deductive logic. It's a technical concept, right? And it's not to be confused with the kind of linguistic practice where we acknowledge that somebody's made a good point, right? So sometimes we'll say, well, you've made a valid point. Okay, we don't talk like that in this class because validity is a property of arguments. And it's a formal property, and basically what it says, or what's true of a valid argument, is that an entailment relation holds between the argument's premises and the conclusion, right? So validity is the property that arguments have if their premises guarantee the truth of the conclusion, assuming the premises are true. Okay, so the conclusion has to be true if the premises are true. That is a concept of validity, right? Now it's a little weird, okay, because validity has to do with form, and form is more of a syntactical idea. It's about how things are arranged. Validity is not necessarily something that's interested in the truth, right? Validity can actually hold in cases where you don't have a true conclusion or true premises, right? And we'll go over some of those cases, right? It's important to keep these two ideas distinct, right? And so here's a little table that might help you, okay? Truth is just concerned with what is the case. So people who are, scientists, they're supposed to be anyway interested in the truth. They're supposed to be concerned with what is the case, right? Now, whereas validity, that's something that logicians are interested in, right? They're concerned with whether or not conclusions follow from a premise. Okay, so you might be interested in this as well as a scientist, but then what you're interested in is providing a good analysis, right? And you have to have a valid argument form in order to do this. All right, especially if you're wanting to make a deductive argument, right? The validity of an argument then stands independent of the truth or falsity of the premises it contains, right? So you can have, right, a well-functioning argument, right, that doesn't have true premises, right, which is kind of a strange idea. Most people find this a little unintuitive. So maybe an analogy might help. I want you to think of valid arguments as being akin to good water bottles. All right, so what's the deal here? Well, right, think of it this way. Valid arguments have a special kind of property, right? They are truth preserving, and that means that the valid argument's premises, right, if they're true, are never going to take you to a falsehood, right? They're never going to take you to a falsehood. You're going to end up in a place that's true. Okay, and a good water bottle is like this, all right? They are water level preserving. Okay, so when you start off from point A and you get to point B, and it's summertime here in South Carolina. That's when I'm giving this lecture. It's pretty hot outside, and you might take a water bottle with you. It would be a pretty crappy water bottle if you started off with a nice full one, and then about a mile later you look down and the thing is like, there's a quarter tank left. That's no good, right? So the same is true of invalid arguments. They're like leaky water bottles, right? Invalid arguments, right, can take you from true premises to a false conclusion, right? So to kind of run with this analogy here then, do good water bottles need to be filled with water, right? And the answer, of course, is no. And so part of an argument's quality, it doesn't depend upon whether or not it has true premises, okay? It can have a good form, right? And so that's something and I said well-functioning, that's what I kind of was talking about, is the argument's form. It has a form that functions well, meaning that it never takes you from true premises to a false conclusion. Right. Now, to kind of illustrate this, there are valid arguments that state nothing but falsehoods. Yeah, this is actually the case. Okay. So again, for those of you watching, I am in South Carolina. I'm assuming that you are all kind of who are taking this class are in South Carolina in some capacity. Normally I teach this in a traditional classroom, so this is a little strange. But if you kind of think about these premises, right, if we live in Louisiana, then our winters are sub-zero. Now I'm assuming here nobody's living in Louisiana while watching this. I could be wrong, right? But just imagine that you're at Clemson University here, and you're talking to me in a classroom, all right, or any college here in South Carolina, right? We live in Louisiana, okay, no, all right, our winters are sub-zero, right? So there you go, okay, there's Louisiana. That's like a model that you could consult to show that all these are false. And just imagine that, you know, all of us are living in South Carolina here, okay? That's kind of one of the things I'm assuming here, all right? Now, this could all be different, though, right? We could actually have true premises and true conclusion so if we were still living in a time where the boundaries of Louisiana were the boundaries of the Louisiana Purchase, okay? And so you could be up here in North Dakota, heaven forbid, or Montana, you know, which I guess would be kind of cool. But you know, and that under that kind of model, well, then these premises then are going to be true, and the conclusion then has to be true. Okay. All right. So if that's not a super helpful example, all right, basically the idea that I want you to kind of understand here is that under the false reading, right, under the false reading, if you have a false conclusion here, then at least one of these premises has to be false. Okay? Because this argument is valid. Why is it valid? Well, if the premises are true, then the conclusion has to be true. Okay? So validity can be thought of then in a pair of if-then statements. This was helpful to me when I learned it, and that's why I just pass it along to you because I think it might be helpful. Right? So here's one way of putting it. Here we're going to talk about the premises, right? If the premises of a valid argument are true, then the conclusion must be true. Yes, that's right. Right? Validity plus true premises is going to guarantee a true conclusion. Okay? That's how it goes. All right? However, you can have validity in the case of a false conclusion. All right? So if the conclusion of a valid argument is false, and that's possible, okay? That's possible. I just showed you that. Then at least one of the premises must be false. Right? You can know that for certain just by virtue of the form of the arguments. Okay? So getting into the formal definition of our concept here of validity, this is a good way to remember it. This is out of the book. An argument is valid in a logical language L if and only if every model in which all the premises are true also is a model in which the conclusion is true. All right, so those models that make the premises true are also ones in which the conclusion is true as well. All right. Now, invalidity is easy to test. Okay, and what we're going to be doing in our homework and in some of the practice problems at the end of this lecture is that you will be asked to test for invalidity. All right, and so what your job there is to do is find at least one model, or at least try to find one model that makes the premises true and the conclusion false. Okay? And if you're able to do that, then you've shown that the argument's invalid. Okay, all you need is one case for validity to fail, right? Validity is an all or nothing type of thing. Okay? So here we have whenever P or your premises P through Q are true, then R is true as well. And we can write that in our notation like so. We have P, those separated by comma, that's a premise, all the way on down to Q, however many premises that you have. You put those in a collection, then the little double turnstile thing right here that signifies entailment, and then your conclusion R. Okay, that's how you would represent a valid argument. Okay. All right, so now I was talking about well-functioning arguments, and an argument's quality isn't only determined by whether or not you have true premises. You also need to have, this idea of soundness. Okay, so what soundness is that you have a valid argument form plus true premises. Okay, so validity all by itself isn't enough to get you a really good argument that has persuasive power. It's a well-functioning argument, but what it's designed to do is preserve truth from the premises to the conclusion. All right. So in addition to that idea, you need some true premises, And when you have valid form and true premises, you have a sound argument. Okay? So formally, an argument is sound if and only if it's valid and all the premises are true. Now, debates in philosophy, all right, usually are over an argument's soundness. Okay? And usually what's being debated there are whether or not the premises are true. Okay, if a philosopher goes to a philosophy conference to read a paper and propounds an invalid argument, it's pretty embarrassing, right? It's something that, I mean, look, it happens to the best of us, but or I don't know, well, I don't know if it does actually. It's a pretty bad mistake, right? People. It's pretty hard to live down if you do this sort of thing. But it's not, though, hard to live down if you offer up some, a defense of premises that are controversial, to be sure, right? But then you kind of have that argument with people that's ongoing. And that's usually what ends up happening when people start debating arguments. Validity is easy to get. It's all or nothing, right? Soundness is too, but usually there is more disputes happening over premises because we're more uncertain about those sorts of things. All right. Okay, so things to note: there are valid arguments that contain no premises, but only a conclusion. All right. So your notation kind of looks like this: you have the empty set, and then you have the entailment relation pointing to R, or entailment relation R, which just means that the so-called conclusion here is a logical truth. All right, so our syntactic idea of an argument of a set of premises and exactly one conclusion is satisfied here. It's just that the set of premises is empty, okay, and that the conclusion is a logical truth, right? It does satisfy the definition of validity because it's impossible for both the premises to be true and the conclusion to be false. That's another way of defining validity, by the way. It's impossible for the premises to be true and the conclusion to be false. And in this case, right, there are no premises, right, to be false, and the conclusion just has to be true, right, because it's a logically truth. All right. Okay, so that is just kind of the basics of validity. I think let's just kind of go through some practice problems here to get a handle on things. All right. So think of this: it's January. January's in the wintertime, and it's wintertime. Is that valid? Well, yes, it is. If the premises are true, the conclusion has to be true. All right. Is it sound? Well, you know what? It's going to depend on the month I'm giving this lecture in. If it's January and it's in the northern hemisphere, then yeah, it's in the wintertime. All right. But yes, it definitely, whatever, it depends. Yeah, it depends on what time I'm giving this lecture. All right. Moving on. Premise 2. Okay. Either President Lincoln was assassinated or he had a duck on his head. He did not have a duck on his head, so therefore he's assassinated. Okay, it's impossible for the premises to be true and the conclusion false, so it's valid. Is it sound? Probably, right? But, I found this on Google and I thought it was funny and I had to work it into my lecture. So there you go. Okay? Either Princess Diana died in a plane crash or she died in a car crash. And she didn't die in a plane crash, so therefore Diana died in a car crash. And now is that valid? Well, sure it is, right? It's impossible for the conclusion to be false and the premise is true. Okay? And is it sound? It sure is. She did not die in a plane crash. There you have a nice example of true premises, right, and valid form. Okay. Brian is a friend of Tammy's. Right? Tammy is a friend of Mark's. Okay, Brian is a friend of Mark's. All right, is that valid? No, it is not. It is not valid. Why? Because friendship is not transitive. Okay, it's just false that if X is a friend of Y and Y is a friend of Z, then X is a friend of Z. Life just doesn't work that way, right? As much as social media websites like Facebook would like to believe that, or that maybe they don't believe that, but they would like that to be true. Okay, that's not how friendship works. Here's another argument. Tom and Fred are hardworking. Tom is tenacious, and everyone who is both hardworking and tenacious succeeds. Okay, so then Tom will succeed. Okay, now is that valid? Right? Think about that. And the answer is yes. Okay, if the premises are true, then the conclusion has to be true. All right. Is it sound? Well, I don't know. Maybe not. It depends on how you're going to define success, right? I mean, if you think that kind of giving your all and being hardworking and tenacious, no matter what you do, is kind of how you define success, well, then there you go. But if you're talking about success and achieving your goals, yeah, life happens. Sometimes you get sick and you can't do it. All right. So and you don't succeed in that sense. All right, so practice problem number 6. All right, I like this one. If Virginia is to the right of Alabama and Alabama is to the right of Texas, then Virginia is to the right of Texas. Hey, guess what? Virginia is to the right of Alabama and Alabama is to the right of Texas. So Virginia is to the right of Texas. Is that valid? It sure is, right? There's no doubt about it. If the premises are true, the conclusion has to be true. But does it sound? Well, it kind of depends on the meaning of the phrase to the right of. Okay, now in the geographic sense, it's obviously the case that Virginia is to the right of Alabama, and there's Alabama there, and Texas, okay? But if you're thinking of to the right of, that phrase in the political sense, well, you notice here that Virginia is a blue state, while Alabama and Texas are red states, and so that ends up being false, okay? So this leads us to what is called the fallacy of equivocation, right? This is a common fallacy. I think it's one that people don't pay attention to very much, but basically it just involves the use of different meanings of the same syntactical representations for different predicates in an argument, okay? So to the right of, okay, that could be interpreted in a political way or a geographic way, right? And so you have to be very clear about what sense you're talking about, right, in order to avoid the monster of ambiguity. Okay, ambiguity often spells the death of many good arguments. All right, so that's why we as logicians really insist upon this precise language and well-defined terms. So we are trying to be we're trying to avoid as much ambiguity as possible, right? Have to eliminate it in order to do deductive logic. All right, so let's just kind of do some true-false questions here. A sound argument is a valid deductive argument with true premises. That's true. That's just the definition of soundness. Okay? A deductive argument cannot be both valid and unsound. Well, actually, it can. It can be valid and unsound, right? Because if it didn't have true premises, right, then it would be unsound. All valid deductive arguments are sound arguments. Of course not. That's just totally ridiculous. All right, a deductive argument can be either valid or invalid and still have true premises. Yeah, it can, right? There are tons of arguments, right, that you can make that have nothing but true premises, right? And they're totally invalid, right? Just because you're saying true things doesn't mean you're reasoning. It's one of the facts of life, right? Okay, when the conclusion of a deductive argument is true, the argument must be sound. That's false. Okay, you could have false premise, right, and still have validity, right? But you wouldn't have a true premise. You need all true premises to have soundness. Okay. Okay, when the premises of a deductive argument are true, the conclusion is always true as well. That's also false. Okay, we've already talked about that. Just saying true things doesn't get you to truth, right? Just because you have a history of saying true things doesn't mean that what you're going to say next guarantees the truth of what you're going to say. You're going to need an argument form for that. Okay? Right, if a deductive argument is sound, then the conclusion must be true. All right? That is, of course, true, because sound arguments are valid arguments plus true premises, and so that's going to have a conclusion that has to be true. Okay? A deductive argument could have a false premise and still be sound. Nope, you have to have all true premises. Okay? All right, I'll let you kind of go through these other ones. There's the idea. All right, I wanted to get to this slide here because this is some stuff that I think is actually important to work through. I give you a number of practice problems here. And basically what I'm wanting you to do is run that test of validity I was talking about. So what you'll do to test for validity is you'll go through this procedure. You'll try to make your conclusion false, and then try to make your premises true. So It's really easy to make Q false here. You just assign an F to Q. Now you have to be consistent throughout. You have to assign F to all the places that Q shows up, right? Now you got to try and make these things true, all right? Now, can we make a P arrow Q true given that it has a false consequent? And the answer is yes, we can give the P a false antecedent. So we'll assign an F to P, okay? We'll assign an F to P. Because what we're trying to do here is be creative and try to think of a way to make this thing invalid, meaning we're going to make this false and these guys true, right? Now notice the other premise here, okay, has a logical truth in its consequent. It also has a false antecedent. Now you need to know, you really need to know your semantics of arrows, because if you have a false antecedent or a true consequent, it comes out true. The only time these things ever come out false if you just have a true antecedent and a false consequent. All right, so we actually have a model here, and I'll just kind of post the answers to kind of give you the idea. All right, is that we have a model that proves that that's an invalid argument form. Okay, what is the model? Well, P is false and Q is false, right? But not so down here. Okay, here we'll make Q false. All right, we'll just assign an F to it. Okay, now we have a premise P. And so we'll assign a T to P to make it true, because that's what we're trying to do. That's the test for invalidity. I'm trying to make a false conclusion, true premises. Now I got to be consistent. So Q is false here, and it's false here, right? Now this is a really big conditional here, right? There's the main connective. Now I see in the antecedent we have a logical truth, so we have a true antecedent, and so here, now we got to figure out whether or not the consequent of that conditional is true or false. And then remember we have a false antecedent right here. We already gave an F to Q. But remember we gave P a true right here. And so here we have a true antecedent, false consequent, which makes this part false. This part is true. This part is false, which makes this whole thing false. And so we failed in our test for invalidity. We were not able to do it, and so therefore it's valid. Okay, this is a little confusing, but I think that you can work through it here just like that, right? There's a bunch of other practice problems you can take a look at. And just one last thing, I want to kind of go over some of the stuff that's on the homework, right? Now I made a separate video about how to do this homework, a little guide, so I'll link to that. There should be a link that pops up right here in the upper corner. Please click on that, it'll tell you how to do that. But understanding the skill that's in the practice problems there will help you figure out how to do those problems in that homework. Okay, so that is the lecture. I hope this was helpful. Please shoot me an email if you have questions, or post your questions in the discussion section of the Canvas page, and I will talk to you later.